Hey everyone, welcome to the channel. My name's Nader. In this video, we're going to go over the last part of object-oriented programming that we've been waiting to get to over the past couple of videos where we've been studying this topic together. In this video, we're going to go over encapsulation. So I mentioned the kind of four main ideas of object-oriented programming: inheritance, encapsulation, abstraction, and polymorphism. We went over inheritance and polymorphism as well as the basics of OOP. This is going to be about encapsulation as well as a new keyword in object-oriented programming called the static keyword, which is going to allow us to do some new things with classes and objects in JavaScript. We're not going to cover abstraction in JavaScript specifically because since it's a prototypal language, it makes it a bit tricky to actually make this work in an easy to understand way. So we'll save that for kind of maybe future programming languages or places where it does make sense to introduce. We can do a lot without abstraction, technically speaking, in most kind of practical applications. So that's totally fine. If you are interested more in abstraction, definitely let me know in the comments and we can kind of walk through some examples together. So without further ado, let's get to encapsulation and the static keyword together. All right, so to start, again, I just really want to emphasize these four main ideas of OOP. Inheritance, which is the idea that we can have a superclass and we can make subclasses based off of that superclass, and we can keep subclassing and subclassing and subclassing and have this entire kind of class hierarchy tree kind of thing going on. Polymorphism, which was we can implement in one way through inheritance that we saw in the previous video, where we can have, for example, many different objects in a subclass implement some kind of method where the superclass might or might not implement it. And if we have a group of those things or a collection of those things, we can kind of have this thing change forms according to what type of object it's operating on. So for example, if we have an array of enemies, we can have each enemy attack in its own specific way, which is pretty cool. In this video, as I mentioned, we're going to go over this concept right here, which is encapsulation, which is a very important part of object-oriented programming. We're going to see how that works, and I'll tease a bit about abstraction, although we'll see that it's a bit tricky to do in JavaScript specifically, so we'll leave that for future videos. So to start, what is this idea of encapsulation? So when you think of encapsulation, I'd like you to start thinking of maybe like a capsule, right? Like really that's where this term really comes from. So when you think of a capsule, like maybe like a medicine capsule, for example, right? You probably like, okay, like I know that this might be some kind of like a cough medication or for a headache or something, but we don't really know what's inside. I mean, like most people, I definitely don't know what's inside most of these capsules. I just trust what's kind of on the box, right? And the idea is that if I have a headache, you know, I can go and get a headache, like an ibuprofen or whatever it is. And inside of that capsule are a bunch of different things, chemicals and whatnot. And I don't really care what the chemicals are as long as they're safe and they kind of do what's on the box, which is get rid of my headache, right? Same for cough and cold, same for pretty much anything that we would take a capsule for. So when you think of encapsulation, definitely think of this concept of a capsule because it literally is in the word as well. So when it comes to encapsulation for OOP specifically, we're talking about classes and how classes are effectively a capsuled version, like a sealed, nice, immaculate version of two main things. And those things are the data as well as the methods that might operate on that data. Okay, so encapsulation really seals these two main concepts and a few other small things here and there into this nice kind of interface that we can kind of look at from the outside and be like, oh, look at this nice class object. It has all these different things, but I don't really care how it works. I just know that it can kind of do the stuff that I'm expecting of it. For example, this enemy might be able to attack, or this player might be able to move, or this car might be able to drive, etc. Okay, so I know this is very abstract, but let's kind of start here and build on with this. So as I mentioned, a car as an example, right? And these are some examples of encapsulation. I think it's really important to think of this from a high level perspective to start so that we can get an appreciation for what this word actually means. So I want you to think about a coffee machine. Right? Maybe you go to a coffee shop, or maybe you're fancy and you have one in your house. This looks like a very expensive coffee machine. Definitely don't have one of these. This looks like something at a Starbucks or something like that. So if you see something like this, you know, even as a barista, for example, right? Even if you're really good at making coffee, you don't really know how the coffee machine works. Right? So that sounds kind of counterintuitive, right? It's like, okay, well, yeah, I know how to make coffee, so of course I know how the coffee machine works. But we really don't actually, right? If you think about it, The coffee machine has a lot of stuff going on. It's a lot of engineering inside of it, a lot of parts. These parts come from all over the world. We have like all these little like very specific parts specific to this coffee machine, maybe that only come from certain factories and things like that, right? So for example, if maybe one of these parts was missing, like imagine we had a coffee machine and one of these parts was missing. And then as a barista, for example, let's say we work at a coffee shop and we're told to fix the coffee machine, right? Of course, we're not going to know how to fix the coffee machine, most likely, right? Unless we're like a mechanical engineer or something, or we tear the whole thing apart or whatever. And even then, it might be kind of tricky, right? So just because we can use it doesn't mean that we know the internal workings of that object. All right. And this really is the key for encapsulation. And it's interesting because this actually applies to pretty much every object that we actually use in real life as well, right? Like think about a car, for example, right? I'm definitely not a mechanic, but I can drive a car, right? I know I have a license, I can drive a car. And I can probably drive a car in different parts of the world. I don't really know how to drive manual, right? So I'll probably struggle with places that only have manual cars. But I know how to drive an automatic car, and maybe I could drive like a bigger car, maybe a smaller car. But I definitely don't know how a car works, right? I generally know that there's this engine in the front, and that there's wheels, and there's like an axle, and then the engine kind of is fueled by gasoline, and some fancy stuff happens, combustion, and all that kind of fun stuff, and it just makes the wheels go around, right? But if you were to ask me to like fix a car, or if you were to ask me like build it from scratch, right? There is no way we would be waiting until the end of time for that to happen, right? I'm definitely more on the software engineering side than I am on the hardware engineering side, at least for something like a car, right? So I think a mechanic, for example, might be more familiar with a car, but even a mechanic wouldn't be able to tell you how to make the exact parts, like from scratch, from the bare metal. Like how, if the like axle was missing, like if we had zero axle, how can we just whip up an axle from thin air and kind of build it from scratch ourselves, right? Like most people don't know how to do that stuff. These are all very specialized things, and they all come from different countries in the world, and each of those countries has their own specific way to do it, and it's a global kind of supply chain, right? That's generally how these things are working, at least in the modern world. So really what we can learn from this is that there are all these objects, and no matter how kind of expert we are with these objects, it's very unlikely that we know the internal workings for these things. However, the important thing is that we can still use them. Okay, so let's think about this again really quick from that context. If you think about a coffee machine, as a barista, for example, or if I bought one for my house and I had a manual, right? I could probably flip through the manual or get some training from the other baristas in the coffee shop, and I could figure out how to use this thing pretty quickly. Sure, there's some, whiz-bang gadgets here and there and knobs I can turn to tune it ever so slightly. I can maybe learn those over time, but generally speaking, I can probably learn to use this coffee machine from a series of instructions or from training from somebody else. Okay, but that does not mean I know how it actually works internally. Okay. So we have an interface to use this coffee machine through these knobs, through these buttons, through these levers, and we can make coffee with this machine, but we have no idea how it works, right? Let's take that to the car example. So if you think about a car, really our main interface to a car are things like the steering wheel, the gas pedal, the brake, the handbrake, things like that, right? And maybe we have like a radio or like a CD player. People still have those, or whatever it happens to be, right? That doesn't mean though that we know how a car works just because we know how to drive a car, right? So think about that for a second, right? We can drive it because we were trained to use a car. So for example, a driver's license, right? The test to get a license, we're trained to interface with this machine, but we don't actually know how it works. In fact, very few people can probably say they really, really fundamentally know how a car works, right? So that is pretty remarkable, right? These objects are really encapsulated. There's a little bit of abstraction going on here, which is why these topics get a little bit muddied up. But really, this is encapsulation. We have these objects that are kind of these capsules of different things going on inside of them. And really, to use them, we don't actually have to know much about them, but we're kind of given these little controls. that we can use these things appropriately as long as we know what those controls are. Right? Now that is a pretty powerful idea, and that really is what encapsulation is all about. So let's take this idea of this capsule here really quick that we looked at earlier and take it to our class examples. So if you think of a class, let's look at it again really quick from this lens now. So a class, for example, in this case, I have a class called player, and it has a constructor which takes the name, HP, MP, and items, right? We saw this in the previous video. We're assigning to the this object, which is the instance of this class right here, right? With these this.name, this.hp, this.mp, and this.items. Okay, so this is the data that is going to be associated with each instance of this player class. Now, this class has really two methods, we can say. It has a constructor method, which kind of comes with all of these classes, and it has our custom one here, which is speak, for example. And this takes a phrase, and it's just going to console log it out along with some data from the class instance itself, in this case, the name. Okay, so what we can really say a class is, it's a combination of data for that instance, along with methods that we can operate on the instances with. And those methods might interface with the data, they might not. But really, it's a capsule that contains these things inside of it, and we can kind of reach in and grab some of these if we need to. All right. Okay, so I would like to kind of take this premise and expand on it a little bit and show you some issues that might come up with this and why we kind of need some new constructs to actually solve some of the challenges that we might see with something like this. So let me show you what I mean. So let's say, let's focus on the code here on the right actually this time to start, okay? So we have here a database class, all right? So if you don't know what a database is, it doesn't really matter. It's not relevant to this example. Just assume for now it's a class and it might like store some data somehow. It doesn't really matter to us how it does it, okay? So in this class, for example, maybe we have a field called token, and maybe it's some kind of like secure token. We of course have our constructor, maybe that has some parameters and maybe it does some stuff in there, that's great. Then we have maybe a save data method on this class, right? And we can maybe pass it some data to save like a string or an object or an array or whatever it happens to be, however this works. And it hopefully just saves the data. But if we just peel back the layers a little bit, just so this makes a bit more sense, maybe this save data method relies on some of these properties inside of this class. I just realized these should all be this.init database, this.authorize, and this.update query, but let's just go with this for now. So what we're saying here is use these methods inside of the class while you're saving the data. So let's just make believe for now, just to pretend what's happening. In fact, we wouldn't really save data this way. It's very inefficient this way, but let's just assume that we're going with this example. So let's say when we save data, we make a connection to the database, whatever that means, right? Then we authorize, again, whatever that means, right? That's some kind of logic or fetching or whatever. And then we do an update query, whatever that means, right? And then maybe some other stuff. And all of these methods are in the class. We just kind of split them up into functions or methods in this class just so that it's not like a whole bunch of logic, like hundreds of lines inside of this one method, right? We can split it up just like we do with regular functions among other methods. Each can do its own very specific thing, and we can just call those methods from within our class method. So this seems pretty good, right? Like if you think about this, like sure, like let's assume this code actually works, right? And this is a good way to do it. So we can say that, yeah, like we have a database class and it's, we construct it and then we give it some data and it hopefully just saves the data and makes the connection and authorizes and blah, 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 blah. Okay, so let's take a look at kind of some issues that might arise even with this simple example. So on the left here, let's take a look at what we're doing. So I have a DB. I'll call that a new database, right? So we're going to make an instance of our database class, right? So we have a DB object in this case. And then we're going to say db.saveData. So we're going to call that method on our DB object or instance that we have. And maybe we pass it like, for example, this object, username monkey, right? And we want to save that to our database. Right now, again, don't focus on what that means, right? We don't really care about saving the data and what that actually does. I just want to focus on the methods and how this code it might be operating and some issues that might happen as a result of this. Now, think about this for a second. these methods down here, right? This init DB connection, authorize, and update query, which we're using in save data. Let's just say that we never really want the developer using our database class to actually use these methods, right? Like, let's just say that we kind of made them as helper methods for ourselves when we created the database class to give to other people to use, but we don't really want other people or other developers to be using those methods because they're really internal to our class, right? Like, we just made them for ourselves as developers of this database to make it easier to kind of do code like this, so that when someone calls our save data function or method, we can just kind of take this code and basically copy and paste it into these methods, right? But the problem is that when we have methods inside of a class, or even if we have these fields inside of the class, right, these properties, check out what can happen, right? Like, let's say you gave me this database class. You're like, hey, Nader, I created this really awesome database. Check it out. All you have to do is create a new database, and then you just call save data and you give it your data, and then you're done. Like, that's it. It saves the data and you can get it out later. Like, let's say we had a get data or something as well in here, right? But let's say I'm playing around. I'm a curious developer and I do db dot, right? And I put the dot there. I'm going to get this list of these other methods in here, right? I'm going to get the init db connection method. So maybe as a developer, I'm going to be curious. I'm going to be like, oh, that seems like I kind of need to do that, right? Maybe I need to do this before I can save the data, right? Maybe that makes sense. Maybe you just forgot to tell me that. Maybe I'll just try it out, right? What's the worst that could happen, right? Oh, this authorize thing also looks pretty cool. I feel like maybe I need to do that as well, right? And update query. Oh, that sounds like I kind of need to do that. Maybe so. Now I'm confused. Do I need to do update query, or do I have to do save data? I remember you told me I have to do save data, right? But what about this update query? Did you make a mistake? Did I hear you wrong? Is there two ways to do the same thing, right? And then what is this thing? I also get this db.token. Like, I never put that in there. Where did you get this from, right? Can I change this? What happens if I change this token? Is it going to break? Right? If I say db.token is equal to something else, is my whole database going to break? Right? So hopefully you can see, right, that we're actually exposing these methods and fields when we don't really intend to do that. What we really want is a nice clean interface so other developers, really the only thing that they can do is db dot, and all they will see in this case, in this particular example, we probably have a get data as well somewhere, but in this particular example, all they will ever see is a save data method. They will not see any of these. That would be perfect, right? Because then they can't mess stuff up, right? They can't like change the token, or try to, call update query by itself, or authorize by itself, or mix up the order of these things, right? So hopefully you can see kind of some of these issues. So I'd like to pull up VS Code actually and go through some of these just so we can really concretely see this. Okay, so I'm going to pull up VS Code here. I'm going to create a new file. I'm just going to call this database.js. I'll zoom in a little bit here just so that we have a bit of a larger picture. I'm going to do the same thing, right? I'm going to say class database. I'm going to create a token here, and I'm going to just set this to like ABC123, for example, just so that we can have it kind of do whatever it needs to do. I'm going to create a blank constructor. And just to kind of copy this, I'll just create some functions here that they're just empty. They don't really do anything, okay? So I'll just do save data, and this takes some data. And inside of here, we're going to call some functions. So I'm going to write out these methods really quick. Init db connection, right? I'm going to say init db connection with nice camel casing going on in there. Then I'm going to have authorize, and that's going to look like that. And then we have update query. It's going to look like that. And inside of here, maybe we'll call all these functions. Except we should do, this is the part I forgot, we need to do this dot that, and then this dot authorize, oh my goodness, typing too fast here, this dot update query, and there we go. Okay, so like I know we're not using data in this case, but that's fine. So let's imagine this is our class. Okay, so that's pretty cool. So how do we use this class? Well, we can say const db is equal to a new database, right? And let's do console.log of our db. Let's see what we get here if we do this. So I'm going to pull up my terminal over here and make sure I'm in the right folder. And I am, and I'm going to run node database.js. Okay, so already we have some funky stuff, right? We kind of are seeing that there's this token in here, right? So notice that this, like, imagine we can't see inside of here. Okay, like imagine we just get this, we import it from a third-party library, or we import it from, you know, your friend's code or your own code or something, right? And all we see is this code right here. We can create a new database and then we're just logging it out. We're already seeing some stuff in here that might not be very good to be able to see, right? This token. So, okay, so like, what is that? The db.token. Can I grab that? Oh, looks like I can. Okay, so, okay, ABC123. I don't know what that means. What if I do this? What if I do db.token is equal to super happy, right? There we go. And then I gotta log out, console.log out my db again, right? Let's see what happens. Okay, well, I mean, hopefully I didn't just break the database, right? Maybe this was needed to do something in the function to connect to the database. I don't know, right? But it's letting me change it, so maybe it's okay. I have no idea. I don't know what this is. I have no idea what it does, right? So this is obviously not good, right? This is very, very bad, right? Definitely not super happy. This is very sad, okay? Other things that are very sad in here are if we do db, right, and I do dot, take a look at this, right? I can do all this stuff. I can do authorize, I can do initdb connection, save data, I have my token in there, I have my update query, right? This is probably not good either, right? The only thing I should be able to do is this one, save data. Like this is fine, right? And maybe I give it like you know, I want to say 1, 2, 3, right? That's fine. This is good. We want to allow people to do that. That's the whole point of the database. But then what is this, right? Like what is this? Why can I do this? Do I have to do this first? Do I do it after? Do I have to do it at all? I'm very confused. I don't know. Let's try it out. Okay, like maybe it worked. Maybe I get an error. Maybe I mess something up. Who knows, right? Technically, what I can also do is I can say db.authorize is equal to like meow, right? I can reassign it. And this would be very bad, right? Because check this out. Now if I do db.authorize, right? Now let's check out what's going to happen. I'm going to get an error because it's not a function. I just reassigned it to be a string, right? This is super bad. This is definitely not what we want to do, okay? Now, of course, you can probably imagine, well, Nader, you know, you can reassign save data to be something else too. But kind of the point is we want to really minimize the surface area that people can mess stuff up and also get confused by our classes, all right? So hopefully you can see that we kind of would be nice to have a way where we could conceal or hide some of these things that are not really necessary to be used, but only show the stuff that we really want the other developers to be able to actually use properly, right? Because you can imagine as our code gets more complicated and we do db dot, maybe we have like dozens of these functions, dozens of fields, right? It would be really confusing if we had so many things in here that we would get overwhelmed and not know what to do. It'd be really nice if we could kind of reduce that to only the core functionality of our database. And all the stuff that we use internally is actually hidden from the developer so that they can focus on what they actually need to get done and our documentation can be more clear. So that would be wonderful. All right, so it turns out that there is a way to do this. And this is a concept in the field of encapsulation or object-oriented programming called information hiding. Okay, but it's definitely a part of encapsulation because we're kind of trying to put this all into a nice capsule so that from the outside in, people don't actually need to care about how this stuff works. They can just kind of call the public methods. So that was the key word there. Let's take a look at how we fix this. So I'm going to show you this. I'm going to switch really quick again from here to here. All right, one more time. From here, apart from the eyes that look a little bit creepy, from here to here, right? What do you think is the difference? Here to here. All right, so it turns out that JavaScript actually has a way to do this, and this is called private fields or private methods, and pretty much a private idea in general, which is an accessor or a privacy kind of flag that we can add to classes. This is actually true of every single object-oriented programming language. In fact, JavaScript actually has less features in this regard than most other true object-oriented language, which makes it a bit trickier to implement other things that we might need. But for now, let's just focus on this. So if you might have noticed, the only change I made here, apart from add these eyes that are staring at us creepily, is in front of all these things that are highlighted as red that I don't want to show to our developers. I just put a hashtag. That's all I did, right? Just a hashtag in front of the name. Now you're probably thinking, what on earth is this, right? Where did this even come from? Like, let's go back to VS Code. Can I do this? Can I say like const token is equal to ABC? No, I definitely can't. That's definitely an error. I can't start a variable name with a hashtag in JavaScript. If I hover over this, I'll get an error in VS Code at least that says private identifiers are not allowed in variable declarations. Okay, so this is kind of being recognized as something very specific. And the reason that we're getting that error is we can only use this hashtag syntax inside of a class. JavaScript has actually reserved this hashtag idea to only work inside classes, which is why we're also getting this error. And it's also not valid syntax outside of a class for a variable name. So how does this actually work? Let's try it out, right? Let's see what happens. You notice here though that I'm actually putting it not only on the field, right, which is basically this .hashtag token, which I could have done in the constructor as well. So putting this in the constructor or putting it out here in the instance methods or the instance properties and fields is actually the same thing. This is just kind of one shorthand for it. But I can also add it to actual methods of the class, notice right here, by prepending or prefixing each of the method names with a hashtag, just like we would for the actual property or field names. Okay, so let's take a look at this. So before I do this, what I want to do is I want to show you something. I want to say console.log back in my database.js here. And I want to do object.get own property names of my DB. Okay, so I'm going to run this and let's see what we get. And I'm trying to do all this meow stuff here. Let me comment that out for now. And okay, so if we take a look at this, it looks like we have token as the property name for our DB, okay, and for the instance of our DB. So if you recall, these are the instance fields or instance properties. The methods are actually stored on the prototype. So let's take a look at what's on there as well. So I'm going to copy this line here. I'm going to do __ proto. Let's see what's on there as well. And okay, so there they are. So we have our token. I'll just bring up my class definition here. We have our token, which is on the instance, which is the instance property right here. Then we have the constructor, save data, init, DB connection, authorize, and update query. They're all right here. Fantastic, right? So that's on the prototype, which is database.prototype, which is the prototype of DB. Okay, perfect. So that all makes sense. So we don't really want this to be the case, right? We want people to not be able to actually see some of these and we want to hide them. So let's take a look at what we can do. So recall that this is what we get. We also see it here, token, when we're actually logging these out. But if I simply do this, check this out. I'm going to add a hashtag in front of token, just like this. Okay. And I'm still going to initiate it to ABC123. If I wanted to access it, I could say this.hashtag token is then equal to, for example, XYZ and then 789 or something, right? And this would reassign it, right? So if I run this code again, what we'll actually see is that, and I actually assigned to token here. So I'm trying to, I guess I'll show this to you actually really quick while we're here. Why not? So if we look at this database, right, when we first construct it, which is what's being logged on line 19, right? Notice that when we create it, there's no token in here. There's no token, right? There's no hashtag token, right? It doesn't exist. This is the name of our property's hashtag token. Okay. Now you might be confused. You'd be like, well, what about super happy? Well, we actually assigned this to the database, right? So this is an assignment here, right? So we just added this as a new property onto our database object, which we can actually do for anything in JavaScript. We can do like some array.hello, and we can say it equals to hello. So this is actually not modifying the class right here. This is just adding this to the DB itself. So I'm actually just going to comment these out because this is actually going to confuse us more. Let me rerun this. So what you'll see is that database now, the hashtag token is hidden and we get undefined if we try to log out token. What if I try to log out hashtag token? Well, I'm going to get an error now because it's going to say we can't access token outside the class database, because it has a private identifier. Okay, so now we're actually getting somewhere, right? We can't do this now. We can't just access it. We can't assign to it. We can't even kind of check if it we can check if it exists technically using another syntax, but we can't really mess around with it in this case. And if we try to do this, this is a totally different name. Just because it has the same name without the hashtag doesn't mean it's the same property. This is actually just the same as trying to grab like hello, for example, like a totally different name that doesn't exist inside this class. To make that exist, we would actually have to name it up here, and we could assign it a actual token. All right, so that's undefined. And notice as well that here, when we're logging out the property names for DB, it's not in there. Previously, we had token in here, if you remember. Now we don't. It's hidden from us again. That's pretty cool, right? So I can't accidentally do stuff like do DB dot hashtag token. Notice it's not even in this list. I don't even have access to it anymore, which is fantastic because I can't accidentally mess up that token if it's needed inside this class to do stuff. So how far can we take this? Well, we mentioned that we don't want these three methods available as well. We only want save data and constructor to be available. So check this out. I can do hashtag in front of the method names, right? And now the only change I'm gonna have to make is now these methods don't exist, right? Because these are totally different names now. I have to prepend or prefix each of these with the hashtag, just like that. Okay, because that's literally what we called it. Now let's run this code again and take a look at that, right? Isn't this totally awesome? Okay, we have made it. So our database now has no fields in it that are outside accessible, right? We tried to log token, of course, it's not there because it's not a property anymore. The instance has no properties. And the actual prototype, which is what we're logging on line 31, right? The actual prototype, which is database.prototype, only has constructor and save data, which if we look at this class are the only two that don't have the hashtag, which are the only two that are public and not private. All right. So token is a private field. Constructor is a public method. Save data is a public method. Init, DB connection, authorize, and update query are all private methods. Now, what we can't do anymore is we can't do db dot any of these private methods. Notice the only thing appearing in here now is save data, which is exactly what we wanted. Isn't that amazing, right? Super, super cool. Now, what I do want to mention here is when people learn this for the first time, and when I learned this for the first time as well, I actually conflicted and confused the idea of a private field and private method with security. Okay? Now, technically speaking, this is not making our code more secure per se. All right. This code still is in there. And if a developer wanted to like open up our class files and take a look through them and change stuff and muck stuff up in there, they can still do that if they want to. We're not really hiding it from them, like encrypting it or putting it behind some kind of password or anything like that, right? It's still there. It's just the language prevents other developers from doing like this db dot something and changing it that way. Okay. So we're mainly hiding it is the way to think about it. We are not really making it like go away completely. It's still in the code base and it's still accessible if people want to tear apart the code and actually pull apart the class definitions. So that's all still in there. So it's not secure in that way. It's mainly just easier to understand from an interface point of view for the actual end user of our library or our class, even if that's just ourselves, so that we don't have this long list of internal functions and fields that are not relevant to someone actually using the class and are only relevant for being used inside the class. Okay. So again, keep in mind that that's the case, and also keep in mind that the hashtag is literally part of the variable name at that point. So we have to include hashtag inside of all of the calls to the methods and hashtag in the variable names as well, just like this. So if I wanted to console.log out the token, for example, say console.log out the token, I would have to say this.hashtag token. Okay. Now, if I did db.savedata, for example, and I run this, what we'll see is we'll see XYZ 789 because that's what we set this .token to be. Okay, so it's this .hashtag token because it's private. So notice again, we can still access it if the class actually does something like console.logout in this case. Or for example, if it even returns that value, we can still access it in that way. Okay, wonderful. Now, I want to show you something curious about this, all right? And this is a little bit of where JavaScript differs from other languages because we are actually missing some keywords that add extra functionality. Now, let's take our database class that we just looked at. Okay, same thing, right? We have our token, constructor, save data, init DB connection, authorize, and update query. And we have made these ones that are in red, right? So everything except the constructor and the save data methods private using the hashtag that we just learned. Okay. Now let's extend this class using the extends keyword to make a subclass. So in this case, I'm just going to call it custom DB. It's going to extend our DB, right over here. And let's kind of take a look at what actually happens in here. So let's just say that I want to make a new token for this database, right? So I'm going to do a hashtag token. This is some other token, right? Oh my goodness. This is some other token right here. Okay, so this is a different token than this one. So that's fine. So these are not going to conflict, right? Each one is going to get its own set of tokens, and we're not going to kind of accidentally try to grab the token from the database in this case. Constructor is public. That's fine. Save data is public. We're overriding this in the subclass. So we're not going to be calling the superclasses save data when we call save data unless we call super inside of this save data. But check this out. If we want to access methods or properties that are private from the parent as the subclass, we cannot do that. Okay. Just like we can't access these private methods and fields from outside the class as an instance, we also can't access them from inside the subclass, because the only time we can ever access private fields and private methods are from within the exact same class that they were defined in. We cannot access them even in a subclass. Even though it's in the prototype chain above us, we cannot do super.initDB connection for this in this case because initDB connection is in the parent and it is private to that parent. The subclass or the child class cannot access it. Okay, so not only does private make it so anyone outside the class can access it, it also makes it so any child or child or child or child cannot access it either. The only place we can access these private fields and methods are inside database itself in this case. And in the case of this token over here, the only time we can access that token or any of the private methods we might add to this custom DB will be inside of the custom DB class. Okay, so just to show you that, I'm going to go back to VS Code here, and I'm going to add another class here. I'm going to say class, let's do custom DB, and this is going to extend our database. All right, so I'm just going to add another token in here, and this is going to be, let's just go like 1, 2, 3, 4, 5, 6. Okay, this is going to have our constructor. Actually, I'm going to leave out the constructor because it's going to call super in this case. And then we had our save data. And this is maybe going to take some data, but we're not going to do anything with it. And in here, if I try to do super dot, now remember, super refers to the database in this case. Literally, the database prototype is what we can think of. Okay, so the only thing that's publicly accessible in super technically are the constructor, which we can do by doing this, right? Which we saw previously, or any of the methods if we do a dot. But in this case, since the only method apart from the constructor that's public is save data, that's the only one that we have access to. If I try to do super.initDB connection, for example, I would get an error. It's not accessible outside the database because it has a private identifier. Okay, so initDB connection can be said to be private to the database class itself. Even the subclass cannot access it. Here, we're just creating our own instance of token and we're overriding it. So for example, we wouldn't be able to access it because it's not on the database itself, it's on the child or it's on the instances, but we would not be able to access this token as well from anywhere. Okay, I know that was a lot, but hopefully you can kind of see where this is going, right? The whole idea of encapsulation is to allow us to make these nice classes that have their own data, that have their own methods, that we can kind of give to others, even to ourselves, and we can restrict what's visible to the outside world, and we can also restrict what's visible internally to us. So we can do all this kind of custom crazy stuff inside of the class itself. And nobody is any wiser. They don't know this stuff is going on because the only thing that they see are the public fields and the public methods that we expose, which is exactly what we want because this is how we can simplify the code. Now, there's a little bit of the idea of abstraction leaked into this concept of encapsulation, as sometimes they work hand in hand like this, but abstraction is actually a totally different concept that relies on keywords that we don't have in JavaScript, like abstract classes and interfaces. They were introduced in a language called TypeScript, for example, which is an extension to JavaScript. These words might come into the language in the future. However, in the base vanilla JavaScript language, that's the standard that everybody has access to, they are not currently available, at least at the time of this recording. So hopefully that changes in the future. Perfect. But private has recently been added because it was a very, very requested and important feature, as you can currently see how important this really is. Previous to this, we had to do really crazy stuff like use closures and things like that to prevent data from leaking outside of the class. And it was just way more complicated than it needed to be, just for the sole purpose of hiding this information so people can't accidentally call the wrong methods or access the wrong fields or change data without it being needed to be changed. Okay. Perfect. Now, to wrap this up, I'd like to show you a new keyword as well, which is kind of the second part of the topic that I mentioned at the start, which is the static keyword. Very, very important. And once we understand this topic, we'll actually start to see a lot of these concepts come together, especially when we're using both third-party libraries as well as the libraries that are built into JavaScript. So that is this keyword right here, the static keyword. So let's take a look at how this works. So again, I'd like you to focus on the right-hand side here to start. So over here, I have a class called utils, okay, just short for utilities. And inside of this class, there's no constructor. It's just a default constructor. But notice that I have kind of two things going on. Let's go through these one at a time. I have this new keyword here called static. But then I'm creating a description, which looks to be an instance property, right? Instance field. And I'm just setting it to be the string, a utility library. So without the static keyword, we kind of know what this does, right? This sets each instance's description to be a utility library, and that's fine. And again, same thing here. We have a method, it looks like. We have a static. We don't really know what that means yet. But if we ignore that, we just know it's a method. It takes a string and returns string.toUppercase, right? So that's fine. That's pretty great. But what is this static thing? Why do we need it? What's this doing for us? Right. So let's take a look. On the left-hand side, I want to show you how this changes the game when it comes to using classes. And we see this everywhere when we're using JavaScript. And I'd like you to think of a couple examples in the back of your mind as we're going through this as well, if you can. So if I do a console.log and I just take the class object itself. All right, now notice here, the most important thing is I did not do this down here. All right, normally what we do is we create const util, for example, is equal to a new utils, right? And I would try to access description and capitalize on that instance of that object. But if I try to do that, I'm going to get undefined, which is kind of curious because well, they're right here. We defined them. So what's going on? Well, when we add the static keyword, we're assigning these fields and assigning these methods directly to the class object itself. In this case, directly to utils. So to access these, we would do utils.description, for example, to access the static description, and we would get a utility library. we would do utils.capitalize, which is the method or function. I think I missed a bracket here, to access the capitalize function, and we would get the high capitalized back to us. All right. So notice again, we did not create a new utils. We never kind of constructed it, right? These are just directly off of the class object itself. All right. So what static is doing is it's assigning these methods and properties directly to that object one time for everyone. There is no longer a concept of an instance where each instance is going to have its own version of this. This is going to be the same for everyone. So there really is only one description and only one capitalize method. Now, technically capitalize, if we were to put this as a method, would be only once on the prototype. But if we were to create fields on instances, each instance would have its own state, right? If you think of like a player, or if you think of our database, for example, the token, each instance has its own state. It's going to have its own HP, MP, it's going to have its own token, right? Which makes sense because that's the whole point. We can take a template and we can create multiple versions of objects of that template. But in this case, if we only need to have one thing for that entire class, and that's never going to change, and it's going to be the same for everything across every single part of that class, we would make it a static field or a static method. So if you think about this, in this case, a description for the class, that kind of makes sense, right? Why would we need the description as an instance in every single object of the class? We can just have it one time as a description for the entire class. So we can just do utils.description. Same with capitalize. In fact, if you think about some of the methods that are built into JavaScript, and I'll pull up a couple as we go through this, a lot of actual internal JavaScript methods work this way. Okay, capitalize, we don't really need to have a class constructed to do this. We just pass it a string and it gives us back a capitalized string. It doesn't actually need any state information or anything else. It just does something the same every single time for every single call. Okay, so I'm going to create a new file. I'm going to call this static.js. And in this file, I'm going to create a class, and let's just call this utils. Right? So I'm going to do a couple things here. I'm going to say static description is equal to like awesome utilities. I can't spell utilities. Oh my gosh. There we go. Oh my gosh. Utilities. They're probably laughing at me as I'm doing this. Utilities. Really hard to spell and type at the same time. I think that's right. Yes, I think that's right. For some reason, that is really messing with my brain, and I actually don't know if that's right, but you know what? We'll just go with it. I think you guys know what I mean. And then we'll say a description in here. And I'm just going to say this, another description. Can't really spell today. Not really sure why. There we go. Okay, so notice that we have one static description and one regular description, whatever that means. Let's do the same thing for a method. So let's just say caps, we'll do static caps, and this is going to take a string, and this is going to return the string.to uppercase. Okay, and I'm going to say another one, I'll just say like lower, for example, just to keep it a little bit different. And this is going to return str.to lowercase. Now notice the difference between these two, this is prefixed with the static keyword. So we can say that this is a static method on the utils class. This has no such thing. So this is just a regular method on the utils class. Huh, interesting. So let's take a look at what we get. I'm going to do console.log. I'm going to do utils.description, and I'm going to do utils.caps. Not .call, .caps. There we go. I'm going to run node static.js, and take a look at this, right? So I didn't create a new utilities class at all here, an instance, right? I just grabbed it directly off the utils object itself, right? So I'm seeing awesome utilities, which is the one that's static. And I'm seeing the caps function, which is the one that's static. Now, if I try to console.log out utils dot, I guess, lower, I mean, we already saw it with caps, but we're going to see that it's undefined. Okay, so the way that we can actually really see this is if we do a console.log of object.getOwnPropertyNames of utils, okay, clear this console out, we can see that utils has length, prototype, caps, name, and description. So this looks kind of confusing. So I just want to mention that length, prototype, and name are actually in the function prototype. All right. Caps and description are the ones that we've been added by us. So everything that's a class is technically a function behind the scenes in its prototype. It's from the function prototype. So that's why we're seeing length, prototype, and name. Those are all from the prototype of function. But what we've added are caps and description. So this is technically the same thing as doing this. I can say utils.hello is equal to the string hello. Right? And if I run this, what we'll see is that now hello is on there, right? So we can think of the static keyword as basically assigning it directly to the class object itself, just like this, except we have a nice way to kind of group them all in one place. And this is in line and very consistent with other object-oriented programming languages that we see like Java or C++ and things like that. All right, pretty cool. So let's create a new instance. So I'm going to say const utils, for example, is equal to a new utils. That sounds kind of strange. And then I want to just console.log out this utils. Let's just see what we get. All right. And it looks like we have a description in there. So that's cool. But this is another description, the instance version of the description. So what happens if I do this? What happens if I do console.log of object.getOwnPropertyNames of utils, and then of utils.__proto. Okay, I want you to think, what are we going to see for these two? See if you can take a guess for both utils and the prototype. All right, let's take a look. So for utils itself, the instance properties are description, which is this one right here, another description, which is the one that we see logged when we actually log out the class with this nice pretty print that we have over here. For the prototype, we have the constructor, which is created for us automatically, in this case, the default constructor, which is what we see, but we also see our method, which is the instance method, which is actually on utils.prototype, which is lower. We don't see caps, and we don't see this other description. Okay. So technically, we can think of the methods and instance properties as being something like utils dot prototype dot, and then in this case, I can say, for example, let's just say camel case, and then I'll just put this as a function for now, just so that we can see that it doesn't really do anything. And if I rerun this one more time, we'll see that now that is on the actual prototype. Okay. We can't get the instance properties on the prototype. Those are on the object itself, which is what we see over here, right? But on the prototype, we can get the methods, which is why we see lower, and then this one that I've added to the actual prototype itself. Now, if this is confusing, the prototype video definitely covers some of this stuff behind the scenes that's going on with the prototype chains and how that works, as well as the intro video to actually classes and OOP in general and JavaScript specifically, since this is all just wrappers really around the prototype chain and prototype hierarchy in JavaScript itself, which is a nice abstraction to actually allow us to think in object-oriented programming terms. Okay. I hope that this was an interesting video for you. There's definitely a lot going on with objects, as you can see, and object-oriented programming in JavaScript in general. If you did find this video interesting, I'd love it if you could like the video and subscribe to the channel. I'd love to hear in the comments if you've used these keywords before. Have you heard of this idea of encapsulation or seen static before and got confused with any of that stuff? Does this make sense? Do you find it useful? Do you think you can see yourself actually using this in projects going forward? I'd also like you to think, where have you actually seen this, right? Where have you seen that you can just do something dot something and get either a function or a value directly out of it? It's an interesting thought. All right. So what we're going to do in the next video is we're going to go over a bunch of exercises really to hammer this idea home, since this is the final object-oriented video that we're going to be looking at together. And following that, we're going to get to the capstone project for this entire JavaScript series, which I'm super excited for. I'm going to make it nice and challenging for us so we can really practice all these concepts that we've learned together over this entire journey. It's going to be a lot of fun. I can't wait to get to not only that, but the exercise videos next. So I'll see you in that one. See you later.